Today's lesson is really a continuation of the same section that covered the distributive property. We certainly covered a little bit about combining like terms while we were going through it, but I wanted to have a more focused lesson on that because this is something like the distributive property that's going to be not just in this class, but it'll be an issue or something, a skill you have to know and use in every class in math from here on. So first I want to make sure that the terms are clear, and then we'll do some examples on combining like terms. So first of all, a variable is a letter or symbol that represents a number. So common examples are x, y, and z. So a variable, not saying you haven't heard this word before, but a variable is a letter or symbol that represents a number. Now, an expression is a collection of numbers and variables with math operations. So math operations would be like addition, subtraction, multiplication, division. It could also be exponents. But it's not an expression if it has an equal sign. If it has an equal sign, it's called an equation, equal equation. But expression is something like what you see down here, 4x plus 3 plus 7y. That's an expression. It's a collection of numbers, 4 and 3, and variables, x and y. And this one just has addition as its operations. And then the individual pieces of the expression are called terms. So a term is a part of a mathematical expression. So that's why I actually put this down here just to make it clear what the terms are. So this expression has three terms. The first one is 4x. The second term is 3. The third term is 7y. So each of these individually represent a different term. Okay, simplify. So if you were told to simplify, that means to reduce to a smaller form by regrouping terms of the same variable. And I should probably say same variable. Let's see, that might be a better way to word that. All right, let's add this on the end. Same variable or variables. When they put parentheses around an S like this, that means it could be just one variable or it could be more than one variable. And exponents. So we'll see that when we do examples on the back, but it has to have the same variables and the same exponents. So just right here to briefly explain what I mean, I could combine 3a squared and 4a squared because both of them have a as a variable and both of these a's are squared. So these are like terms. However, if I had 3a plus 4a squared, these two are not like terms because even though they both have an a, this one is squared, this one is not. So they have to have not only the same letter, the same variable, but also the same exponent. So like terms are parts of an expression whose variable patterns. So the variable patterns is really what I was trying to describe up here, having the same variables and the same exponents. And so their variable patterns are the same. So variable patterns means same variables, same exponents. And there's another example of two like terms. So here's an example already written out. Now, it says combine like terms. Another thing they could have said here is simplify, using that word right up here. So simplify is another direction they could have given here. So to simplify, we'll have to combine the like terms. So as you look through here, we have four terms, 2x, 5x, 4y, and 3. We have operations, addition, subtraction, and addition. So they circled 2x and 5x because they have the same variable pattern. They both have an x in them, and it's x to the first power. So these two are like terms. They can be combined. 2x plus 5x equals 7x. This term, 4y, does not have any like terms because there's no other term in this expression that has a y. So that's why they simply rewrite this exactly the way it was. It was minus 4y up here, it was minus 4y in the original, so it stays minus 4y. This also has no like term because it's a constant. That means it's a number without a variable. And since there is no other term that has no variable, this is by itself, has no like term, it just stays as it is, plus 3, plus 3. So when a term has no like term, you just leave it as it is and don't change it by combining it with anything else. So 2 more terms we need, then after we talk through those, we'll do some examples. So coefficient. Co means together. So a coefficient is a number that is in front of the variable. So it's a number that is with, co means with, a number with a variable. So in this example down here, 4 is with the x cubed, so it's a coefficient. 2 is with the x cubed, so it's a coefficient. 3 is, sorry, I may have said x cubed here. 2 is with the x squared, so it's a coefficient. 3 is with the x, so it's a coefficient. So these 3 numbers are coefficients because they are with a variable. They are in the same term as a variable. However, the 1 over here is not with a variable. So that is a constant. So a number can be either one of these, but it cannot be both at the same time. So a constant is a number that stands by itself without the variable. Constants are like terms to each other because they don't contain any variables. So that's the same variable pattern because the pattern is there aren't any. So make sure you understand the difference between coefficients and constants. So now that we've talked about coefficients, constants, and like terms, let's simplify each of these questions. So simplify again means, if possible, reduce it into a shorter form with fewer terms. So we've got to see what the like terms are. So just in case this looks like a 5, this is an s, so 12s plus 5s. Those are like terms. Their variable pattern is the same. S to the first, S to the first. So then we just say 12 plus 5 is 17, and we keep the variable pattern with it. So if you have 12 S's and you add 5 more, you have 17 of them now, 17 S's. Number 2, 6m plus 8 minus 3m. So I just like to move from left to right, but it's up to you how you want to do it. So I just look first at 6m. So I think, okay, the variable pattern there is an m. So I want to look for another term in here that has an m, and we see one right here. And you want to keep whatever operation or sign is in front of each term. So we see it as a positive 6m, a positive 8m, and a minus or a negative 3m. So these two are like terms. So I can go ahead and say 6m minus 3m is 3m. And then I've covered those. So there's only one term left, so it obviously doesn't have a like term because it's by itself, and it's 8. So the like terms got combined. The thing that had no like term just stayed the same. Number 3. 5y squared plus 2y plus 7y squared. So again, I start with what's on the left. I see 5y squared. So this time I'm not looking just for y, I'm looking for y squared. So this is not a like term to the first one because this does not have a squared. But this is a like term to it because it also has a squared. So these two have the same variable pattern because they both have a y squared. So 5 plus 7 is 12, and I keep the y squared. So I've got those two pieces covered. And then just like the previous example, this has no like term. There's no other term with just a y in it. There are two terms with y squared we can combine, but this is the only term with a y, so we just have to leave it as is and write it as 2y. Okay, number 4. If I start with 5k, so I'm looking for things with k to the first power, just k, no exponent. So this one is not a like term because it has k cubed, so different exponents means it's not a like term. This one is a like term because it's k to the first and k to the first. Let's keep going because there can be more than just 2 like terms, so it'll depend on the problems, but there can be 3 or 4 like terms you can combine. So you should always go all the way across. Don't just stop because you find one like term. Keep going and see if there's any others. But in this case, there are not. There's no k here. There's a k cubed, but that's a different story. So I'll first start by combining 5k and 11k. 5 plus 11 is 16, and I keep the k. So I've covered those two. So I'll look now at 4k cubed. So a like term is one that also has a k cubed. So that would be this one right here. So these two are like terms. So we do 4 plus 9 is 13. And we get k cubed. So 13k cubed. Because you had 4k cubes, then you added 9 more of them, so you have a total of 13k cubes. Number 5. I'll start with a 4. That's a constant. It has no variable. So if I'm looking for a like term, we need to see if there's another term that also has no variable. Well, this has a variable, but this doesn't. So it's a like term. It's another constant. This has a variable, so it's not a like term. Like I said, keep the operation that's in front of the term. So this minus is attached to that 2 and cannot be detached. So I look at this as 4 minus 2, and I get 2. And I've covered those two terms. Then I see a term with an x squared. This term also has an x squared. So I do 5 plus, because that's what's right in front of this term, 5 plus 4, which is 9x squared. Last example, we're going to combine our distributive property with combining like terms. So just thinking like we would with the order of operations, we look first to see if there are like terms inside of the parentheses to see if they can be combined. Well, these are not like terms. This variable pattern has an f and a g. This variable pattern has only a g. So the parentheses has been simplified as much as it can be. So next we need to deal with the multiplication before we deal with the addition. So I multiply 4 times fg, which just gives me 4fg. Then I do 4 times 3g, which gives me 12g. So I'll start here, look for like terms. I'm looking for another term that has f and g with it. Well, no other term has an f in it at all. So this has no like term, so I just have to leave it just as it is. Then we have 12g. So the variable pattern here is to have a g to the first power. This also has g to the first power. So I get 12g plus 5g, which is a total of 17g. And 4 plus 17 is oh no, wow, look, I almost made that mistake. Don't do that. I wish I could say I made that mistake on purpose to make a point, but I didn't do it on purpose. This is as far as we can go because there's no more like terms. But you can tell it's tempting. You just want to make things down to one term. It's what we want to do, but we can't because fg cannot combine with g. They have to have the exact same variable pattern in order to be combined.